Lewis McCann.
I'm Brandon Fuller.
And I'm Gary Malone.
Collectively, we're students at Coventry University, just completed our first or second years of a creative computing degree.
We've been working with Cogent Computing for the past 6 weeks developing an augmented reality project. The task for us was to create a way to visually represent sound virtually in a real environment. By using augmented or mixed reality, we can overlay computer-generated objects when viewing the world through a webcam. Here we're using fixed virtual microphones and a rotating speaker to represent an approximate location of sound. The position of the speaker is determined by the levels of sound received at different points in the space.
In order to capture the sound data in the room, I've been using tiny computers called gumsticks with an attached audio board and microphone. These can then be programmed either individually with Python or using a centralised program such as Sensor, which is what we used in the final project. The Sensor program was developed by Dan Goldsmith and takes a centralised program and then fires it out through Bluetooth to these gumsticks. There were some problems with Bluetooth at first. It was very slow in transferring the data from the sticks to the PC, but with some clever programming by Dan and using some report suppression on my side so that only minimal data was sent, we were able to improve the speed dramatically, and now it runs at relatively close to real time.
For this project we needed some 3D models that would be displayed in the room. For this we used an application called Blender. This application is open source and it's very powerful for a free piece of software. These files could then be exported into OpenGL.
Here we can see the microphone in 3D space. Attached to the microphone is the animated note. This was programmed using OpenGL. OpenGL is an application programming interface, or API for short, that is used to create 3D graphics in the room. The module was used to test to see if the implementation could work before moving on to the next stage of development. We could have used DirectX instead. However, it is Windows based, so OpenGL was the only option to use for a cross-platform application. The application was written in C and C++. As viewed is a small sample of the source code.
We used the AR toolkit because it's a fully developed API which is used for marker detection. It'll give to the computer the camera rotation and the camera location, and we can build on it very easily and it'll suit our project perfectly. Here you can see we've created our own marker and we've attached a virtual microphone to that marker.
In this example we're using a real gumstick here with the microphone to collect data from an MP3 player playing through these speakers. Above we can see the tag and the virtual microphone, and when sound's played from the MP3 player the microphone will turn red according to how much sound data it's receiving. A musical note's also shown flying into the mic, which would indicate to a user that sound's being received.
In this final version we've added a localization algorithm. What happens here is the program will take values of sound from different sensors around the room, and using these sounds it will position where we believe the sound to be. On this screen here you'll see the green speaker flying around. This is currently actually where the sound is.
We built a 3D model of the room in Blender to quite painstaking detailed scale, in order that the augmented objects could interact with their surroundings and the computer would know where objects were in the room and also the dimensions of the overall environment. This is the initial version of the room, which is simply the walls and floor. Then we start adding more complex objects such as tables, you can see the blackboard, and then we enhance the lighting, give colours to the objects in the room. Then we add more detailed textures, and finally photo textures for a perfect finish.
In this final demo you can see that we've attached the model of the room to the markers as well as the microphone. Here you can see Lewis blocking one of the tags from the camera's view. This forces the application to just show the real world instead of the virtual representation. As we rotate the camera around the room, the camera tries its best to find a marker in sight, and as it switches between different markers you can see the different angles which the room are being drawn at. Obviously it's not perfect at the moment, it is a work in progress, but with larger markers and a better lit room this should be a lot more accurate.
We would like to develop this application and combine it to a game engine such as Augur or 3D Crystal Space. This would allow an easier system to add physics or collision detection, as well as future possibilities.